Hey, what's up everybody? Mr. Smith here again. In this video, we're going to continue to talk about polynomial equations. Particularly, we're going to talk about what happens when you try to graph polynomial equations. So after this video, you will be able to understand this joke right here. These graphs are asking what's going on with this guy. And he says, don't mind him, he's just ah. So you'll be able to understand that joke at the end of this video. So here we go. End behavior is the first thing we need to talk about when we talk about graphing, graphing polynomials. So end behavior just means this. What happens as the graph goes to positive and negative infinity? So if I have a graph and it looks like this, I want to know the end behavior is what is the graph doing as I move this way along the x-axis, and what does the graph do as I move this way along the x-axis? That's all end behavior asks. Okay? The way we determine the end behavior is that we need to look at two things. The leading coefficient of a polynomial, remember that's the very first number that you see in front of everything. The leading coefficient tells you what the right side of the graph does. If the leading coefficient is positive, the right side goes up. And if the leading coefficient is negative, the right side goes down. Okay? And I'll show you an example of how all this works here in a minute. The other thing we need to look at is the degree of the polynomial. Remember, that's the biggest exponent that we see. So the degree will tell you if the sides match. So if the right side and the left side match or if they don't. An odd degree means that the sides don't match. And an even degree mean that the sides do match. Okay. So let's do an example where we actually put these principles together. That'll probably be the most helpful way for us to start getting our head around how to do these things. So let's take a look at an example here. Maybe I can zoom in a little bit. We're going to graph in number one here. We're going to graph this polynomial. Okay, notice how that it doesn't look the same as some of the other ones we've looked at because it's been factored. So it's not all multiplied out, it's been factored. Okay. So again, we need to look at two things first. We need the end behavior and we need the degree. Okay. Or the leading coefficient and the degree. Those things will tell us what the end behavior is. Okay, so we need the leading coefficient and we need the degree. So the leading coefficient, I look in front, and it doesn't look like there's anything there, so I know that there's just like an imaginary 1. And I'm really looking for the sign of the leading coefficient. So it's positive. The leading coefficient is a positive number. That's what I care about. And then the degree, notice how right now I don't see any exponents. That's because this thing's been factored out. So if it's been factored out, here's how you find the degree. All we need to do is count up however many x's I see. So there's 1, 2, 3 x's. So that means the degree is 3. Okay? So let's go back to our rule right here. The leading coefficient tells you what the right side does. If it's positive, the right side goes up. If it's negative, the right side goes down. So here the leading coefficient is positive. So that means the right side of my graph is going to be going up. Okay? Let's think about how to get the left side. The degree will tell us if the sides match. Odd degree means they don't match. Even degree means they do match. So let's go back over here. This is an odd degree polynomial. 3 is an odd number. That's what I mean when I say odd degree. 3 is an odd number here. So since it's an odd degree, that means that the signs do not match. Okay. So if this one's going up, that means this one needs to be going down. Right, so that means that the end behaviors are flip-flopped. The right side's going up, the left side's going down. I'm just going to write it like that with arrows. Right? The zeros simply mean the solutions of the graph, where the graph crosses the x-axis. We just finished that chapter. In order to find the zeros, all I need to do is look at the numbers for each of those factors and change their signs. Okay, so this one would get me a -1. This one would give me a +1, and this one would give me a 2. So those are the zeros. All right. To get the y-intercept, what we're going to need to do is plug in 0 for all of the x's, and that's what the y-intercept is. So let's come down here and do that real fast. X plus 1, x minus 1, x minus 2. So I'm going to plug in 0 for all of the x's, and we'll see what happens. 0 plus 1 is 1, 0 minus 1 is negative 1, and 0 minus 2 is negative 2. So I'm just simplifying each of those things, and then I'm going to multiply this all out. 1 times negative 1 times negative 2, that's all positive 2. So that's what my y-intercept is. I can come up here and say that the y-intercept is at 2. All right. So now I got everything I need to graph this. I know this might seem kind of like a convoluted process right now. I know there's a lot of pieces running around. We will practice this in class, so don't let it freak you out right now. We're just trying to get a basic understanding of what we're after. I'm going to go first. I'm going to plot the zeros on my graph. So those are the x-intercepts, right? Those are the solutions. So I'm at negative 1, I'm at 1, and I'm at 2. So that's where the graph crosses the x-axis. And I can graph the y-intercept that's up here at 2 on the y-axis. Now I'm going to put in the end behavior. So the right side of the graph, after I cross the x-axis here and move on towards infinity, I have to go up according to my end behavior. And on the left side, I need to go down according to my end behavior. Okay. And now to get the rest of the graph, I just need to connect dots. So from here, the graph would come up here. I'd touch the y-intercept. I have to come back down and cross the x-axis right there. And then I would cross it and come back up where I cross the x-axis again. You might ask, well, how far do we go down right here? How do we know how far this graph goes down before it comes back up? And the short answer to that question is that we don't really know. We'd have to plug in some points to figure it out. So right now, as long as we get a little bend, we cross the axis and we come back up, we don't need to go down forever. I just want to see that we cross the x-axis, we come back up to hit our other solution. Okay. So there's an example of how to graph a polynomial. Let's do one more, and then we'll practice some in class. Let's do this number 2 real fast. So again, we need the leading coefficient, and we need degree. Well, the leading coefficient, again, I look in front of everything. There's no number, right? And there's no negative sign, so I know that it's a positive. Degree, I just need to count the x's. There's 1, 2, 3. So that's the degree. All right, so positive leading coefficient means the right side goes up, and odd number degree means the sides don't match. So that means the left side needs to go down. Okay. The zeros, well, I know this one will give me a negative 2. I know this one will give me a positive 1, because remember, I'm switching the signs. But this single x right here, we talked about this a little bit in the last chapter with solving quadratics. Solving quadratics. This single x term is just going to give me an x-intercept of 0, okay? Because I can think of it as like x plus 0, and that's just the same thing as x. So that gives me a 0 at 0. And then the y-intercept, same thing. I need to plug in 0 for all my x values. So it's x, x plus 2, x minus 1. So if I plug in 0 for every one of those, it's going to be 0 times 0 plus 2 times 0 minus 1. I don't even really need to think about this too much because I'm multiplying all this stuff by 0, right? So that means my y-intercept is just going to be 0. So we go to the y-intercept. Now we've got everything we need. We can go ahead and plot everything. My zeros are at negative 2, 1, and 0. And my y-intercept is also at 0. That's fine. That just means my y-intercept is at the origin. Okay, not a big deal. My end behavior, I'm going up, going left, or I'm going down on the left, I'm going up on the right. And then I can just connect the dots. I have to go up, I have to come back down to my y-intercept, and then I come back up there to where I cross the graph. Okay. So I know these two examples were kind of similar. We'll do some more in class when you guys are in here with me, and we'll give it a little bit of practice. Right now I'm just trying to give you the gist of what we're doing. All right, so let's think about something else that'll wrap up this video. One more thing that we need to talk about. And it's this thing called multiplicity. Okay? So here's what multiplicity is. Multiplicity is the power or the exponent that you see, the exponent of each factor in a polynomial. So let me give you an example. Let's say I have a polynomial that looks like this, x plus 2 squared times x minus 1. Okay. Well, this first term is getting raised to the second power. So this factor right here has a multiplicity of 2. That's how we would say it. This factor, x plus 2, has a multiplicity of 2. This one, remember, if you don't see an exponent written, technically it's getting raised to the first power. So we want to keep that in mind. So this one has a multiplicity of 1, all right? So it's just whatever the power for each individual factor is, that's what we mean when we say multiplicity. The multiplicity tells us something about the graph. If the multiplicity is 1, okay, similar to how this one is right here. If the multiplicity is 1, that means at the graph, at the x-axis, your graph is going to cross at that 0, at that solution. Okay. If the multiplicity is odd and it's not 1, so meaning like 3 or 5 or 7, something like that, we're going to do this weird thing that we call crossing with a bend. And then the last scenario, if the multiplicity is even, that could be 2, 4, 6, something like that, we are going to bounce off of the x-axis. Right? And I know you might have no idea what I'm talking about, and that's okay. I'm going to show you what all of this means here in an example, and then we're going to practice it a little bit. So let's do this one right here. I have x minus 1 times x minus 3 squared. All right, well, again, I'm going to start the same way I started the other one. I need to find the sign of the leading coefficient, and I need the degree in order to get the end behavior. So the leading coefficient. I looked in front. There's no negative sign, so that means the leading coefficient is positive. That means the right side is going up. Okay. Degree. Again, I just need to count the x's. Well, I have 1 right here, and I have 1 right here. But we need to pause, pump the brakes for a second. This term is getting raised to the second power. Okay. So that technically means that this is x minus 3 times x minus 3, right? That's what that means. So technically, there are 1, 2, 3 x's right here. So if you have an exponent running around, you need to count this as the number of x's associated with that factor. Okay, so my degree is actually 1, and then this guy, because of this squared term, actually counts as 2 x's. So my degree is 3. Okay. So it's an odd degree. That means my signs don't match. And I got to go down. Figure out what my zeros are. And I just got to switch the numbers inside the parentheses. So I have 1 and 3. My y-intercept, if I plug in 0 for the x's, it's going to look like this. It's x minus 1, x minus 3 squared. So I'm going to plug in 0, 0 minus 1, 0 minus 3. It's going to give me negative 1 times negative 3 squared. And negative 3 squared is positive 9. Negative 1 times 9 is negative 9. Okay? So now we have everything we need. My y-intercept is negative 9. I got everything I need to graph this. Okay? Let's plot the zeros. I'm at 1 and 3. And my y-intercept is down here at negative 9, which is right up there. And in behavior, I go up to the right, and from the left, I'm going down, okay? From the left, I'm going down. So that is moving down from the y-intercept, which is okay. So there's my end behavior there. Now we need to try to plot our points and get the rest of the graph in there. So this is where the multiplicity comes in, because I'm going to look at each one of these factors one at a time. This is getting kind of messy, so I'm going to clean it up a little bit. I'm going to look at each of these factors one at a time. I'm going to ask myself what the multiplicity is for each of them. At 1, that's the 0 associated with x minus 1, this thing has a power of 1, right? So when I have a power of 1, that's the multiplicity. I cross the x-axis at the solution for this factor, which is 1. So when I come up to 1, that means I am going to cross the x-axis right here. So I'm going to come up from the y-intercept and cross the x-axis at 0. Okay? Well, let's think about that for the other factor, x minus 3 squared. That gives me a 0 of positive 3. Okay? We talked about that the multiplicity of this thing is 2. It's being raised to the second power. That means the multiplicity is 2, which is an even multiplicity. And when I have an even multiplicity, that means I bounce at 0. So let me show you what that looks like. That means at 3, which is the 0 associated with this factor, instead of crossing the x-axis like I did here, instead of crossing the x-axis like I did here, I'm going to come up and I'm going to bounce off of it and continue to go up, which makes sense because my end behavior needs to go up from 3. So instead of crossing it, I'm going to hit 3 and bounce off of it and keep going as I move towards infinity. Okay. All right, so I know that might be a little bit confusing right now. It's okay if you're not a pro after watching this video. We're going to spend some time working on this in class. So thank you guys for bearing with me through this one, and we will see you guys next time.